Today we're here at Astranis Machine Shop. We've got some machinists here, and we're gonna take a look at some videos on the internet, some of the coolest machining projects out there.
This big old massive chessboard, check it out. Oh, check it out, boom.
Oh, here we go. This is a classic Titan's chessboard.
See, that's what I'm talking about right there.
Fancy 5th axis, Kinematal tools.
It's that 3 fluid, that's gotta be at least 3 inches.
Yeah, that diameter to length ratio is pretty long.
Oh my God, I love that clear coolant.
Yeah.
We need that in our machines.
The board's cool. You know, it's a big block of aluminum, but the chess pieces are cool.
People probably don't appreciate how complicated that was.
That's what I'm looking for, because you get more definition in those.
There
Here we go. Here we go.
Yeah. How long do you think it takes for those chess pieces, programming and making each one of those?
Ooh, man, I'm thinking he'd probably spend a whole month on that.
Yeah, at least.
We need to make that. That project is up next in our CTX, for sure.
There's so much definition that being put into that. And plus, I don't even know what type of material the pieces were made out of.
I think they were titanium.
Titanium is not forgiving. I have nightmares about it.
It can be more difficult than certain materials. I don't find it more difficult than like a 316 stainless steel, because 316 is kind of gummy, which it fights with your tool a lot.
Titanium's all about feeds and speeds. I mean, you start getting into exotic materials and you get into these crazy parts. It's all about the basics, your feeds and speeds, the type of tool you're using, the type of tool path. So biggest things is quality tools. We use Helical, Iscar, Walter. So you want to go to those tool manufacturer websites and you want to pull off the feeds and speeds to be able to machine stuff like this. Oh, here we go. Some titanium. What are they making? Wow.
Dude, is that an octopus? Wow.
Jeez,
Look at
you
that.
see the roughing on that?
Yeah.
I actually saw this octopus in person.
The definition into the scaling of the octopus, that is just insane. And they're not even breaking 90. I mean,
No.
that thing is just right there. Look at that rigid. Oh, that holder gets so close to the base.
They're actually using a heat shrink holder to rough out a lot of that material, which is what we do here often too.
I love them. The rigidity that you get, the precision, very minimum run out on the tools, and just how easy it is to just swap it out.
So they're going 400 SFM on that? That's insane.
On tie, it's pretty crazy. You can't just make up feeds and speeds and have at it. You'll start breaking tools. It's not going to be good.
That's why when I saw that 400 SFM, I'm like, whoa, hold on now.
Yeah.
Because like most companies will tell you, hey, keep it on the lower side, like around 250, 300 SFM.
Yeah.
But
400 is definitely pushing it.
Yeah.
That means there's an applications engineer, manufacturing engineer over at Kinematal, I'm assuming, that knows their stuff. So
yeah.
pretty cool.
But also
to see.
too, that was Titan. Titan always pushes everything to the max.
Titan pushes everything to the max.
When I first saw this, the only thing I was thinking about wasn't how pretty it was. I was thinking about how expensive that piece of a material was.
That block of titanium is huge. For perspective, this block of titanium is about $1,500 nowadays. So that piece, I don't know, what, $10,000?
I'd say at least. I would probably go like 15 at max.
Yeah.
We have this part here is for our satellite, but you can see, like the octopus, we had to rough out a lot of material to make this happen.
See, like, if you compare that part to the octopus, I could probably say octopus would be a little bit easier to machine.
If you're ranking them, yeah, I would agree. If I had to pick and choose one project or the other, I'd take the octopus all day
I'd rather
long
take the
because,
octopus all day.
one, it's fun, and I
Yes.
feel like it's almost easier.
And it's not going up the space, so it doesn't have to be perfect.
Yeah.
All right, I changed my answer. I think that's like $25,000 worth of material.
I want to make something as complex and pretty as that, so if anyone has an idea of what we should make, let us know.
Hey, shout out Titan. We'd love to have you here if you ever want to.
I appreciate all the videos and giving us the insider look and how complicated these parts can be. I know a lot of people don't think about it often, but there is a good career that you can make in machining. So if you want us to react to any other videos, comment them down below and then we'll get to it.
Subscribe to our new channel.
Yeah.